Hey, everybody.
Hello.
Hi, April. How are you?
I'm fine. How are you?
I was sick last Wednesday. Does that affect anything? I
Uh-uh.
wasn't here. Okay. All right. Just want to make sure.
No, but the video's up and loaded into YouTube if you want to watch all the fun you missed.
Yeah, I did. I sure did. Okay. Thank you.
Okay. I just got back from taking my cat to the vet. He has a urinary tract infection. Fun time. Oh my God. Not
How
been using
old?
the litter box. Huh?
How old?
He's 11, almost 12.
Wow.
Yeah. So, and he had some matted hair that I could not get out, so they shaved that off. So he's got some, shaved spots. So he's looking lovely right now.
It will
He's
grow
not,
back.
he's not happy.
He'll get over it.
Yeah. He'll enjoy when I have to shoot the amoxicillin down his throat later tonight too. They always love that. God. Pet ownership. So much fun. All right, well, it is 4:01, so I'll start with, does anybody have any questions about anything? Math-wise, I'm sure you've got lots of questions about life in general. All right, then I am going to share my screen with the PowerPoint. And let's go back to the top. Soup. There we go. And that looks good. And close that out. All right, I'm ready if you're ready. We're covering 3.5 today and 4.3 on Wednesday. And they're already assigned in my math lab, so they are open and ready to go. And in this section, we're going to be looking at how graphs move. We're going to look at how they do vertical and horizontal shifting. Vertical means up and down, horizontal is left and right. Then we're going to look at how, actually they got them in reverse order here. We're going to do number 3 next. How they reflect around the x-axis, which would be like rotating like this. I don't know if you guys can see me or not. And then rotating around the y-axis, which would be like this, which I always relate that to a weather vane. You know, if you got a weather vane on top of a barn, it's usually in the shape of a rooster, and it spins like this, that would be a reflection around the y-axis. And then we'll do compressions and stretches. We'll talk about those when we get to them. So let's start with vertical and horizontal shifting. Okay, last week we went over the basic type of graphs. Let's see, one of them was the x squared. Another one was the square root of x. We also did the absolute value of x. We did 1 over x and x cubed. I think that, oh, and a cube root of x. I think those are the 4 that we, or the 6 that we did. Remember, x squared is a basic parabola that sits on the graph like that. And then the square root of x, I gave it the little, there's a little, that's what that looks like. And then the absolute value of x sat right on the vertex, and it was a perfect V like that. And then 1 over x, that was the reciprocal function, which was in quadrants 1 and 3. And then an x cubed, it went through the origin, and it went through 1, 1, and -1, -1. Those were specific points. So here, here, and here, and it had this kind of an S shape to it. And then the cubed root of x basically did the same thing, except its shape was a little different. It went like this. I'm not real good at sketching. Okay. So those were the basic graphs. I don't think we did anything else. All right. So when we're going to shift them either vertically or horizontally, it's going to be those basic graphs, except they're either going to go up or down for vertical, or they're going to go left or right for horizontal. So the first one that they give you says use the graph of f of x equals x squared to obtain the graph of g of x equals x squared plus 3. And then they ask you to find the domain and the range. Now, this is their explanation, and I'm just going to leave that there for you to read at your leisure. The next one is where I like to explain it, which is with a picture. The original function, which was y equals x squared, I think this is a little thick. That is this graph right here. It's sitting right on the origin, and it's a U-shaped, right? And they just gave you 5 ordered pairs right here. Here are the x's, and then they plugged it into the x squared, and they got the y's. But then what they did is they said, well, what would we get if we plug them into an x squared plus 3? And they got these y coordinates. So when they plotted this x with this y, they got this graph. And it's basically the exact same graph, except this thing got shifted from here up 1, 2, 3. And this point got shifted 1, 2, 3. And this point got shifted 1, 2, 3. 1, 2, 3. 1, 2, 3. Do you see what's happening there? When you add the 3 to the x squared, it's just going to move the whole thing up 1, 2, 3. Just moves up vertically. And then they did it a second time. Oh, and then they asked for the domain and the range. It's a parabola. The domain on a parabola is always negative infinity to positive infinity, because the domain is how it stretches across the x-axis. And it looks like parabolas are only going up, But as they go up, they do go out gradually. So eventually, if it keeps going and going and going, it's going to stretch across the x-axis. Now, the range is different. The range is where this thing bottoms out, and it bottoms out right here. So the lowest point is the vertex, and that one has the coordinates of 0, 3 right there. So the range starts at 3 and includes the 3, and then it does go up to infinity because the arrows are pointing upward. And remember, the range is, you know, how it looks vertically, lowest to highest point, which is, I think, what they said, right? Yep, here's the range, 3 to infinity, and here was the domain, negative infinity to positive infinity. So if you want to shift up, all you have to do is add to your x squared. Or if I went back to any of these, if I had added 3 right here, let me use a different color. How about purple? If I had put a +3 on this, then this graph would have started here, and then it would have gone 1, 2, 3, and it would have shifted to here, and it would have looked like that. If I had put a +3 on the absolute value of x, then it would have gone 1, 2, 3. It would have shifted from here to here, and my v would have looked like that. That's what happens. On the cube root of x, if I had added 3 to that, this point would have gone up 1, 2, 3 to here. This point, 1, 2, 3, and this point, 1, 2, 3. And so now the graph would look like that. It just literally has the same basic shape, just move it up 3. And I could do it the other ones too, but I'm too lazy. Okay. All right, now if you're gonna shift down, same thing, except you move down, you're subtracting. So the original function is the f of x equals x squared. And they want us to look to see what happens when we do x squared, but put a -4 on it. And again, this is their explanation. I'll just show it to you with their picture. So here was the original graph. Here is my x squared graph. And then once again, these were the x coordinates. They plugged and chugged to get the y coordinates just like before. But this time, the new function is x squared minus 4. So when they plugged the x's in here, these are the new y's that they got, which when they plotted the points gave them this graph. And the only difference on this one is this point here went down 1, 2, 3, 4. And this point went down 1, 2, 3, 4. 1, 2, 3. The whole thing just shifts down 4 because it's a -4. And that's all that's happening. If you think about it, these coordinates right here, these are my y coordinates that I got from the x squared. And then you're just gonna subtract 4 from it. 4 minus 4 is 0. 1 minus 4 is -3. 0 minus 4 is -4. 1 minus 4, you know, it's just, they're going down. They're 4 smaller. So it just shifts down. That's all there is to it. As long as you've got some points, you can just shift them up or down. And then this slide just gives you the definition of it. If a positive real number k is added to the output of a function f of x, then the graph of the new function f of x plus k, you're just adding some plus k onto it right here, f of x plus k, is going to be shifted vertically up k units. And then same thing for the next one, except it's saying for y equals f of x, if a positive real number k is subtracted from the output of y equals f of x, Then the new function, y equals f of x minus k, is shifted vertically down k units. Forgot to highlight added up here. Is added to k is added, and down here k is subtracted. But it has to be the entire function. Now, that one makes the most sense. I'm adding, I go up. I'm subtracting, I go down. That's for vertical shifting. Now we're going to look at horizontal. And horizontal's slightly different. It says use the graph of f of x equals the square root of x to obtain the new graph of green. G of x equals the square root of x minus 2. Now this time they're putting the minus 2 under the radical. When I went back and showed you this one here, when I did this, I didn't put that plus 3 under the radical. I had the square root of x and the square root sign cut me off, and then I put the plus 3 in there. Now what we're looking at, the plus 3 has to be outside of the original function. The original function was the square root of x. The original function is x squared. The original function is the absolute value of x. It has to be separate from that. But if you put it right with the x, all right, like they did here, they've got the square root of x and they put the minus 2 underneath it, which is completely different from this. Do you see the difference? This one, the minus, hello. This one, the minus 2 is not under the radical. Whereas this one, it is. It's with the x. Over here, the x is separate. That's going to make a difference. Okay. So once again, they've got their big long out verbal directions here. But I want you to look at the graph because that makes the most sense. Okay, so the original graph, when they graphed it, they just chose these x coordinates, 0, 1, 4, and 9. They picked those numbers because they're square rootable. Whatever you pick for x, you have to take the square root of it. So they made it purdy. They picked 0 and 1 and 4 and 9. They could have gone with 16, 25, 36. You know, there's a bunch of them. They plugged them in here, and this was the y coordinate that came out. And that resulted in this graph right here. However, when you put, what did I do, green before? Yep. When you put the x minus 2 under the radical, and you'll notice they picked different x's here. They picked 2, 3, 6, and 11. That is because whatever you pick for x, you have to subtract 2 from it. So you want to get a 0, a 1, a 4, and a 9, so you can square root it. If you pick 2, 3, 6, and 10, then you're going to have the square root of 2 minus 2. Then you'll have the square root of 3 minus 2. Then the square root of 6 minus 2, and the square root of 11 minus 2. This will be the square root of 0. This will be the square root of 1. This will be the square root of 4. This will be the square root of 9. That gave me the original, these over here. 0, 1, 4, and 9. And then when you square root them, 0, 1, 2, and 3. Okay, but what happens is you're seeing x minus 2 and you're probably thinking, oh, I'm supposed to shift to the left. No, what ultimately happens is you shift to the right. In order to get a 0 in here, you need a positive 2. And positive 2 is right here. It's right there. So you actually have to go 1, 2 to the right. And then this point went 1, 2 to the right. And every point goes 1, 2 to the right, so that you end up with this graph right here. So when you're shifting left or right, it's actually the opposite of what you see. I see an x minus 2 under the radical. Since it's under the radical, it's actually the opposite. You want the positive 2. So you shift to the right 2 places. And when they plugged and chugged the numbers, just to show you what happened, you can see it does move to the right. If it were to say, I think the next one, and then on this one, my domain for the final answer, now on this one, because I've got this, thing, it starts right here and goes to the right. My domain starts here at 2 and includes it and then goes to infinity. But the range, it looks like you're only going to the right, but you're very slowly going up as you go to the right. So your range, this is my domain. My range, the lowest point right here is at the 0. So my range is 0 to infinity because it starts low and continues up high. And if I go back one slide, I will see that the domain is 2 to infinity and the range is 0 to infinity. Now, what if they have a plus sign in here? All right. Starting with that original function again, which is f of x is the square root of x. So I'm looking at, this guy going like that. But then they take him and they put a plus 4 on the inside. In order to get, since I have the square root of x plus 4, in order to get the square root of a 0, this guy right here has to be negative 4. X has to be negative 4 so that you'll get a y coordinate of 0. So this graph is actually going to shift 1, 2, 3, 4 places to the left. It's going to be here and going like this. And here's the picture. There it is. Here's the new graph right here. Whoosh. The black one was the original. And you can see it went from here, 1, 2, 3, 4. This one was 1, 2, 3, 4. They're all 4 to the left. Remember, you're trying to shift this graph horizontally, which means that you still want your y coordinate to be 0. You don't want the graph to go up or down. You want it to go, to the right or to the left. So this number right here, whatever you pick for x and plug and chug, has to give you that y of 0. Because if y was not 0, it would go up or down. You want it to go left or right. So it's got to be the actual opposite of what you see. And that's what they tell you on this slide. If the argument x of a function f is replaced by x minus h, and if you look at it carefully, they're putting the minus h inside the parentheses. Previously, it was f of x, and then they put like a minus h right here. Now they're saying f of x minus h. It's inside the parentheses. So it's with the x. Whether you're dealing with an x squared or the square root of an x or a 1 over x, or an absolute value of x. If it's this situation, it'll look something like x plus 3 squared, or the square root of x minus 2, or 1 over x plus 1, or the absolute value of x minus 5. It'll be right with the x, not separate from it. Everything I just wrote in the purpley color, those are all examples of shifting left and right. Left and right. This one would shift left 3 units. This one would shift right 3 units. This one, since it's a +1, will go left 1 unit. This one right here will go right 5 units. And that's what they're saying on this one. If it's an x plus h, it'll shift horizontally left. The x minus h will shift horizontally right h units. But it's got to be with the x, not separate from it. Okay, and now they give you one example where they put the two together, where it's gonna shift both vertically and horizontally. Now, when I look at this, what I see is f of x equals, and then I see the absolute value of an x. I see a +3 and I see a -5. But everything that I see in the yellow, I'm seeing, I don't have much room to draw this. I'm seeing this graph. It's an absolute value graph. Y equals the absolute value of x. That's what I'm seeing. But then, because we have a +3 inside, let me draw some. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Because I have a +3, this point right here and every point is going to shift 3 to the left. If it's a +3 inside, it's going to go 1, 2, 3. So the first movement is going to be this. Then I have this -5, which means this point is now going to come down 5. So it's going to go 1, 2, 3, 4, 5. And my final graph, or the final location of the V, would be right there where the green is. This would be my final answer for the graph. And then they ask you, what's the domain? Well, it's a V, just like a parabola. It spreads across the entire x-axis, so -infinity to +infinity. However, the range, this thing, when you look at it, its lowest point is right here, which was at -5. And then the V goes up, so it goes to infinity. And then, of course, here's their picture, which, you know, is exactly what I just did. It's right there. This was the original. Boop. This was the original. Then, because that's what they're saying, y equals the absolute value of x. Then when they looked at the x +3, it shifted it to the left, 3. And then when they added in the subtraction of 5, that's when it went down 5 and landed right there. So this would be, in blue, would be what y equals the absolute value of x +3 looks like. And then in green is y equals the absolute value of x +3 -5, because it shifted down. Questions on that? Shifting. Up, down, left, right. North, south, east, west. West, east, whichever way I just said. Remember, this plus 3 was inside the absolute value. So it's going to go left or right. This 5 is outside the absolute value. So it's going to go up or down. Since this one's a -5, it goes down. Since this was a plus 3 inside the absolute value, it's going to go 3 to the left. That one's going to be the opposite. The horizontal actually moves opposite from what you see. All right, and then what's next? Compressions, all right. Compressions and stretches. All right, this is when you're now going to throw a coefficient onto the x. So for example, we're starting with our original function of f of x equals the square root of x. But then they're going to throw onto that a 2 times the square root of x. Now keep in mind, whatever you plug in for x, you take the square root of it. But then you're going to multiply it by 2. It's going to be twice as big as what it was. So here's the picture. The original graph is the swoosh. That's my favorite name for that. It's this guy right here, right? But every single one of your points will still have the same x coordinate. It's just the y coordinate gets twice as big because you're going to multiply 2 times whatever you got when you took the square root of x. And you can see that this point here has a x coordinate of 1, and so does this point. But the y coordinate, let me hang on a second, wrong color. Come on, computer, there we go. All right, so this y coordinate matches that y coordinate, but compare the, I said that wrong, those are x coordinates. Compare the y coordinates. This one's 1 and this one's 2. 2 times 1 is 2. Compare the next y coordinates. This one's a 2, that one's a 4. They have the same x's, they're both 4s, but the y coordinate is twice as big as the original y coordinate. And then this last point, the y coordinate is 3. This one is 6 because it's twice as big. And what happens is it makes this graph stretch up. It's actually stretching closer to the y-axis. If I had had y is equal to 7 times the square root of x, then instead of 1, 2, I would have had 1, 7, which would have been right here, 1, 7. And instead of 4, 2, I would have had 4 times, 4 would be the square root of 2. The square root of 2 times that would be 14. I would have had 4, 14 way up here. And then this graph would have been like that. So the larger this number gets, the closer the graph like stretches, and it's getting closer to the y-axis. It's stretching really tall and trying to make itself skinny looking. Hope that makes sense. Okay, but what if that coefficient is a fraction? Well, instead of being twice as big, this time it's half as big. So when the coefficient is a fraction, then you're doing a vertical compression. When you have a fractional coefficient in front, it's going to make all of the original y coordinates smaller because it's cutting them in half or taking 3/4 or whatever the heck the fraction is. As long as it's a proper fraction. Do you guys remember proper and improper fractions? 3/4 is a proper fraction, but if you flip it over to 4/3, that's improper. This situation only works with proper fractions. Improper would actually be a whole number, like 1 1/3, which would then be a stretch. not a compression. It's got to be a proper fraction for this to work. And so a compression means, and I'll show you the next picture, that again, the original graph is the black one, which I like to highlight in yellow. This is the original graph. And they got all these x coordinates over here. They took the absolute value of them, which gave them just the positive value, and that's what gives them the v. But then on this other one, they then went to taking 1/2 of whatever you got when you took the square root of x. And when you look at it, 1 is half of 2. 1/2 is half of 1. 0's half of 0. 1/2 is half of 1. 1 is half of 2. Every one of these went down by, it was half of what it was before. Half of 2 is 1, half of 2 is 1, except half of 0 is still 0. I wonder why they didn't plot the 1, 1. The 1, 1 point was right here. Here's 1, 1. And then it moved down to here, which is still 1, but 1/2. This was -1, +1, and this is -1, 1/2. I don't know why they didn't plot those for you. But if my fraction was even smaller, like let's say it was y equals, I don't know, 1/10 of the absolute value of x. If I had 1/10, then, oh God, the absolute value of 2 is 2. 1/10 times 2 would be 1/5. This would be 1/10. This would be 0. This would be 1/10. This would be 1/5. So now I would be getting, I'd still have 0, 0. At x is 1, I'd have 1/10, which would be like right there. At 2, I'd have 1/5, which would be kind of like there. So it's going to be more like that. So it's compressing down. It's compressing, and it's getting smushed closer and closer to the x-axis. So stretching makes it skinny, compressing makes it fat, widens it out. That's the best way I can explain it. And then this slide here puts it all in writing for you. It tells you that if, let's see, when the right side of a function is multiplied by a positive number a, the graph of the new function y equals a of f of x is obtained by multiplying each y coordinate on the graph by a. The new graph is a vertically compressed if the a is between 0 and 1. This is your proper fractions. And then it'll be vertically stretched if a is greater than 1. So this would be your whole numbers or improper fractions. Okay, I'm going off the screen, sorry. Okay. Okay, now that's when you multiply it on the outside. What if it's on the inside? Well, it'll be the reverse. You can see up here, they put the a in front of the entire function. So that would be like if you had 3x squared, or 5 times the absolute value of x, or 7 times the square root of x. That's what they're saying up here, okay? But down here, and they didn't do a slide for this one, they didn't show a graph on this, but if you put the a inside right along next to the x, okay? Then, if the argument x of a function y equals f of x is multiplied by a positive number a, then the graph of the new function y equals f of ax is obtained by multiplying each x coordinate of y equals f of x by 1 over a. And you're going to get a horizontal compression if a is greater than 1, and a horizontal stretch if it's between 0 and 1. So it's kind of backwards. Up there it said vertical compressed and then vertical stretched. Now it's saying horizontal compression for a is greater than 0 and a horizontal stretch for the one that's a proper fraction. It's in between. So it would look like instead of x squared, what you'd have is like a 3x in parentheses squared. Or you'd have the absolute value of 5x. Or you'd have the square root of 7x. The number is with the x inside either parentheses or your symbol for absolute value or square root. Or an x cubed. Or a 1 over x. Okay. And the last concept is, oh yeah, reflections about the x-axis and the y-axis. And that's when this thing flips or spins. So it says graph the function f of x equals negative x squared and find the domain and the range of f. The original function, which would have been f of x equals x squared, that was this guy, right? The only thing that is different now is you're sticking a negative in front of it. It's going to be negative of whatever you got when you calculated x squared, which means all of your y coordinates are going to flip over. So like, for example, whatever this point is right here, and I don't know, let's say it was 1, 2, 1, 2. Let's say this was at 2, 2. Your y coordinate will now be negative. X will still be 2, but then your y will be negative 2. So this point that was here is now going to be there. And its mirror image that was here will now be over there. And this thing just literally flips upside down. It reflects around the x-axis and flips down. And then they showed you a picture right here. The black one was the original. The blue one was the new graph. It just flipped upside down. And I know they're making charts and picking points and plugging and chugging, but ultimately that is all that happens. When you go from y equals x squared to y equals negative x squared, it just flips it around the x-axis. Now, oh, and here's what they're saying. When the right side of the function y equals f of x is multiplied by a -1, which simply means there's a negative in front of it. Here's that negative. You're putting a negative in front of whatever the original function is. I don't know why I like to use yellow for my original functions, but I do. Then it's going to reflect about the x-axis. So for example, if I had an original swoosh like that, which would be y is equal to the square root of x, if you put a negative in front of that square root of x, it's just going to flip it upside down like that. It's going to reflect around the x-axis. The trickiest one probably is y equals x cubed. Y equals x cubed goes through this point and the origin and that point, which does this. Okay, but if I make it y equals negative x cubed, now it's gonna flip. You have to imagine, try to think, you know how a bicycle goes like this when you pedal, right? Yeah, you're pedaling on a bicycle. like if one pedal's here and one pedal's there, again, I don't know if you can see me or not, but I hope you can, and you pedal, then they switch places. That's what I'm seeing on this graph. I see this point here. Well, when I pedal it, it's going to move down here. And this point's going to move there. And then it's going to look like this. So the blue one would be negative x cubed because the whole thing just flips. Okay. All right. Now, what if that damn negative is with the x underneath the radical or inside parentheses or inside the absolute value? Now we're looking at, this one's the square root of negative x, but it would be the same as if you had it like this or like this or like this. They're sticking that negative in with just the x, not the whole function, just the x. How is that going to change? Well, here's that picture. That is when you're going to get the old rotation around the y-axis. If the negative is on the complete function, then we're doing the bicycle thing. It's flipping. It's flipping around the x-axis. If the negative is with the x, right next to just the x, then we're flipping this way, like a weather vane, flipping around, spinning around the y-axis. So I didn't make a table of values, but I could for this one. The original one, which would be in black, they picked x is 0, x is 1, and x is 4, 0, 1, and 4. And when they plugged and chugged those in, the original y's that they got would be the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. But this time in blue, this is going to be the square root of negative x. Now, you can't take the square root of a negative, so that means the values that you choose have to be negative. So look what happened. They still had 0, but now they're using -1 and -4 so that they get a double negative. Now they're picking still 0, but -1 and -4. The square root of 0 is 0. But if you have the square root of a negative x and x is -1, that gives you the square root of +1, which is 1. Boop. And then the same thing for the 4. It'd be -4 square root. That's a positive. And the square root of 4 is 2. What ultimately happens is this graph ends up over here in quadrant 1. It spins around. You can think of this as a pivot point, and it just spins around. Sorry, I said the word pivot, and all of a sudden I just remembered Ross from Friends going, pivot, pivot. Anyway, if you've ever seen that show, it's hilarious. Okay. So anyway, when the graph of the function y equals f of x is known, the graph of the new function y equals, and you can see that they put the negative with the x, that's going to reflect about the y-axis. So examples, let's see. If I were to do, let's say, 1 over x. 1 over x looked like this, okay? But if you make it 1 over negative x, let me do it over here next to this one. If you have 1 over negative x, this thing is going to rotate around the y-axis. So this is going to be over here, and this is going to be over there. If I have y equals, I did the square root one. Ooh, well, absolute value of x, the only problem with that one is this is the original function. if you spin that 180 degrees, if you have y is equal to the absolute value of negative x and you spin it, guess what? It lands on the exact same spot. So nothing funky happens with that one. Same thing with the parabola. The parabola just spins 180, so that ends up looking the same. But on y cubed, let's do the y cubed. Remember y cubed, 1, 1, 1, 1, intersects here, intersects there, and it goes like that. Okay, well, if we do y equals negative x cubed, it's going to spin this way. So my son is calling me, if you can hear my phone, and I am not answering. This point here is now going to be over here. So it's going to be here. Origin will still be at the origin. And then this point here is going to move over here. And that spins it around the y-axis like a weather vane. All right. So let's see what my math lab is going to throw at us. There are about four of these where they give you a whole bunch of equations, but only 4 graphs. And in order to get it on my PowerPoint, I had to do some cutting and pasting, but you will have those, little boxes down here, and you'll pick one and drag it down and plop it in the box, okay? But to get them on here, I cropped it out so I could, look at it. Okay, color code. Let's start with this one. When I'm looking at this one, it's an upside down parabola, right? So at a minimum, I know that it has to be something with an x squared in it. And it's upside down, so it's got to be a negative x squared, right? So anybody that has a negative and an x squared, this has a negative x squared, so it could be this one. This has a negative x squared. And this has a negative x squared. All right. The next one is another parabola, but it's smiling at me, so this is going to be a positive x squared. So this has a positive x squared. This has a positive x squared, and this has a positive x squared. So it could be any of those. This guy, this guy and this guy, these are both absolute values and they're upside down. So their absolute value of x is with a negative on the outside. Remember, anything that flips vertically around the x-axis, that has a negative on the outside. So it would have to be either this one, that has a negative absolute value of x. This has a negative absolute value of x, and this one has a negative absolute value of x, which means this one and this one and this one are definitely not usable at all, So I narrowed it down that way. I am now going to look at the pink one. The pink one, if you can look at it, let's see, it's labeled 10 by 10. Are there 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so this right here has been shifted up 5. So it was flipped upside down, but it was shifted vertically by 5, so that it has to have a +5 in it. And where is negative x? Ah, here it is. It's this one right there. This one is that graph. Next, okay, this one got shifted to the right, 1, 2, 3, 4, 5. But when it goes right or left, that is when it's going to be inside the parentheses. And because you went to the right, it's actually a minus 5. So that one is this guy. This one is, that's why I would drop to that one. Okay, so I am now done with pink and blues. I'm down to the greens. I'm going to do the last one first because that one went up or down. When I'm looking at this one, it went up one. I need a darker green. Boop. It went up 1, 2, 3, 4, 5. Up or down, you just put it on the outside. So that's a +5. So that one is this guy. He goes there. And this one went 1, 2, 3, 4, 5 to the left. So it has to go inside the absolute value. But because it went to the left, it'll be a +5. So that one would be this guy. That was fun. All right. Let's do another one like that. Okay, so I'll just do them one at a time. The first two are both positive x squareds, right? I see a positive x squared and a positive x squared. This one is a negative absolute value of x, and this is a positive absolute value of x. That I know for sure, based on how they're smiling or frowning at me, and if they're curved or straight. Straight V's, that's absolute value. Curved guys, those parabolas, that's your x squared. Smiling is up, going down is negative. Okay. This first one, he is right on the origin. He did not go up, he did not go down. He did not go left, he did not go right. But he sure is skinny as hell. So he got vertically compressed towards the y-axis. So there's got to be some kind of a number being multiplied on to an x squared, and it's got to be a positive, and here it is. That's got to be this one. It's a positive 5x squared. Okay, so anybody with a negative x squared is out. Negative x squared, negative x squared. Okay, so I took those out. The next one, go with orange. He got moved up 1, 2, 3, 4, 5. So that's a vertical move of +5. And there isn't any other that has a stretch on it, because it looks like it's just your standard parabola. So that was this one. So now I can take out any other x squareds, which that's the only other x squared. Okay. Now, let's go back to, I have a neon green. And make a neon green. Where's a neon green? It's not working. There we go. Okay. This one, let me do this one. This one moved up 1, 2, it looks like. It just went up by 2. However, nope, there's no fractions in there. It just went straight up by 2. So that one is this guy. This one goes right here. All right. And the last one has a negative on it. So anybody else with a positive, he's out, positive's out. So I've got 3 that have negatives. So let's look at those. This one here, it didn't go left, it didn't go right, it didn't go up, it didn't go down. It stayed right at 0. But if you compare this one with this one is much tighter. it's tighter to the y-axis than this one is. This one's a much wider V. So it got compressed or stretched down, but it's smushing against the y-axis. So it should be a whole number, and that would be this one right here. It's a negative and a whole number. It didn't go left or right, so it can't be that one, and it didn't go up or down, so it can't be that one. So it's got to be that one. It's the only one I had left. And there you go. Okay. All right, so much for matching. Now, they want you to write the new equation. Find the function whose graph is the graph of y equals x squared, but is shifted to the right 5 units. Remember, if you go left or right, it's got to be with the x on the inside. So here's the x. Since I'm going to the right 5 units, inside, that would be a -5. So my answer should be x minus 5 in parentheses squared. The next one says, same function, y equals x squared, but is shifted down 3 units. You're going down. So that means you're just going to take the x squared, and then to shift it down, you'll put a -3 tacked onto that. Not inside parentheses. It's x squared minus 3. Just take the x squared and go down 3. All right, this one, you got the graph of y equals 6 cubed root of x, but this one is reflected about the y-axis. Excuse me. When you're doing it around the y-axis, the negative has to go on the inside, right next to the x. So that's the only change I'm going to make on my 6 times the cube root of x. I'm going to make the x a negative. And then this one says the graph of y equals x cubed, but is vertically stretched by a factor of 5. It's a vertical stretch. So you're going to take this x cubed and you're simply going to multiply by 5. That's vertically going to stretch it. Now, had it said horizontally compress or if it had said vertically compress, then I would have said y is equal to 1/5 x cubed. If they say by a factor of 5, that's a reciprocal because you're compressing it, so it's got to be a fraction. But if they say by a factor of 5, it's 1/5. Okay, now, number 14, in order to get the answer correct, you have to do this in the steps that they tell you to. It says find the function that is finally graphed after following the following transformations are applied to the graph of y equals the square root of x in order listed. Okay, so for step number 1, you've got this y is equal to the square root of x. They want you to shift it up 8 units. Okay, well, the only way this would change is I would put a +8 on that. So when I go to step 2, what I have now is this. Now they want me to take that and reflect it about the x-axis. If you're going to reflect it around the x-axis, the only change you're going to make is putting a negative in front of the entire function. The entire function. which means I have to put parentheses on there. And if I distribute it, it's going to look like that. So that when I get to step 3, I'm now going to alter this function. And this one says reflected about the y-axis. The only thing you're going to do is stick a negative right there to make that happen. And so my final answer will be this. This is what I'm going to put in this empty spot right there. It'll be the negative of the square root of the negative x minus 8. But you got to do them in order. So it's like you make the first change and like, okay, now how do I change that? Okay, simplify it. Then how do I change that? All right, let's look at another one. This one is y equals the square root of x again. So this is what we'll start with. For step 1, we're going to take the y equals the square root of x. And they said, all right, we're going to reflect that about the x-axis. To reflect it around the x-axis, all you do is stick a negative in front of the function. That's it. So when I get to step 2, I am now going to alter this. And I'm going to alter it by, you're going to shift it up 2 units. To take this and shift it up 2 units, I'm just going to add a +2 over here. So then when I get to step 3, I'm now going to alter this. How is that going to change? And that is going to change by shifting it left 4 units. In order to shift it left, you have to put it under the radical. So I've got to extend my radical out. And I'm going left, which in my head is negative, but for this, it would be a positive. So my final answer that I'm going to put here will be, they've already got the y equal to, so I will have negative square root of x plus 4, and then outside of the radical, a +2. Step by step by step. 1, 2, 3. Okay. All right, this one's going to make you use the graphing feature. It says start with the graph of a basic function. Okay. Start with the graph of a basic function. That is huge. There we go. And when I see the basic function, it is an x squared. But then it has that +2 on it. Let's see. Graph the following function using techniques of shifting, compressing, stretching, and or reflecting, and find the domain and the range of the function. So all they're doing is taking the basic graph and adding 2 to that. So it's going to, the original graph always started at the origin. And remember in math lab, you only need a couple of points, but that point is going to shift up to here. And then if x is 1, like if I made a table of values here, and for the blue graph, if x is 0, 0 squared plus 2 is 2. If x is 1, 1 squared plus 2 is 3. And that's all I really need from my math lab, because you know my math lab will give you this. Takes 2 points and boom, there it is. That's all I'm going to need. The domain is, and type it in interval notation, it's a parabola, so negative infinity to positive. But my range, my lowest point at this point is that +2. So it's +2 to infinity. Now I am going to jump over to math lab. And what question was this? Number 16. I know you can't see it right now. I'm gonna have to share this in a second. You are sharing your screen. I wanna do a new share. Where is it? Okay, log me out of my math lab. Okay, there we go. Okay, so here we are, x squared plus 2. 2 parts remaining. Click to enlarge the graph. This is a parabola, so I click on the parabola, and I know my first point is at 0, 2, so boop. Oh, sneaky. Sorry about that. I just hit the graph and it gave me a parabola. It gave me the graph of y equals x squared. Not x squared plus 2, x squared. And then this little thing popped up, which tells me, do you want to vertically stretch it, horizontally stretch it, vertically shift, or horizontally shift? This is a vertical shift of 2. Oh, and then they've got a box to say reflect and reflect. All I'm going to do is click on this and move it to 2. Oh, look at that. The graph moved. Did you see that? That's all I need to do. I guess hit X. I just shifted it to where it needed to go. Oh, cool. Check answer. Nice work. Thank you. 1 part remaining. What's the domain? That would be boop, and negative infinity to positive infinity. Bam. Nice work. And then the range would be, I need a bracket, and then a 2, and a comma, and infinity, and a parenthesis, and bam, well done. Thank you. Okay. I'll go back one. What if they said similar question? Is they change it on? No. Hey, that's the same damn question, x squared plus 2. Oh, well. That's how you do that. I'm going to go back to my PowerPoint. There we go. All right. Number 18. That's one I probably should have jumped to. Start with the graph of a basic function. Graph the following using the techniques shifted, blah, blah, blah. So you're going to, the original function, let's see, the basic function for this one would be y is equal to an x cubed. That's my basic function. But this has a -1 in it. So my basic function is going to shift to the right 1 unit. I'm going to shift to the right 1 because of that. And then because of the +2, that is going to shift up 2 units. So the original x cubed would look like something like this. And then I am going to take, I don't know, how about this color? I'm going to start with my origin. That point has to go 1 to the right and up 1, 2. It would land here. This point would go 1 to the right and up 1, 2, which would land here. And this point would go 1 to the right and up 1, 2, which would land here. So my new graph I will do in gray would look like, oh, like that, something like that. Now, the domain and the range on this, because they both go up and down, and eventually it does. I know it's going up, but it's going out eventually. And I know it's going down, but it's going out. So both of these are negative infinity to positive. Both of them. Okay. I got a minute. I can do it. I can do it. This was number 18. All right, so here's my math lab. You have to know what the basic function is, because when you click on the graph, you've got to tell it, well, they're only giving me two choices, the parabola and the cube. So I guess that's all they're going to give me. And then just click on the graph anywhere and it shows up. There is your x cubed graph. That's the one you've got to move. And because it was I'm not doing any compressions or stretching because there's no number in front of the x. There is a -1, so that's going to be a horizontal shift, but to the right one, so move that. And then there's a vertical shift of up 2, so 1, 2, and it just moved it. Save and check. Nice work. Yada! I think I picked the right screen. Can you see my PowerPoint again? I've got two more. And I'm right at 5:15, so I will have to finish these last two next time. Alrighty, has anybody got any questions? Going once, going twice. All right, I'll see you on Wednesday. Bye. Bye, Kellen. Unless you got a question?
Nope, I'm good.
All right, bye.